Good evening to all. Today we are going to take up another topic which is for dynamic balancing of rotor. So in this video we will go for dynamic balancing of rotor having single impeller or single stage. So basically we should understand what are the allowable unbalance of the rotor for particular application. So we have taken two guideline or two standard. One is API guideline, another is ISO 1940. So as per API guideline, residual unbalance gram mm is equal to 6350 into mass of rotor in kg divided by speed in rpm. So residual unbalance per plane will be is equal to or equal to total residual unbalance. So whatever number this comes from using this formula, which will use as a residual unbalance per plane. That means normally rotor is balanced in two planes in compressor system. Similarly for ISO 1940 guideline, residual unbalance gram mm is equal to 9549 into grade into mass of rotor in kg divided by speed. So what are the grade? If you want to calculate for grade 1, you have to put grade 1. If you want to calculate 1.5 grade, you have to put 1.5 it is. If you want to go for 2.5, you have to put 2.5. All other all other data will be remain same. But in this case, residual unbalance per plane is equal to half of total residual unbalance using this formula. Normally grade 1 is preferred. So allowable unbalance of rotor. So this is single stage rotor or single impeller. So first of all you have to find out residual unbalance of shaft, mass and operating speed, because first we have to do the balancing of only shaft. So that is why you need to find out these allowable residual cases for only shaft and operating speed or design speed. Next you have to again calculate the same thing where shaft and other attachments or impeller nut all are attached. Same way you have to calculate. The change will be the mass of the shaft and change of the mass of the rotor. Speed will be remain same. So in both the cases you have to calculate the residual unbalance in case of only shaft or in case of rotor. Both. Now balancing of rotor, so first we have to calculate or we have to find or select the balancing planes. So balancing plane selection criteria is this: balancing is done in two planes, as you know, so selection of plane is very important. So balancing planes are shall be such that both planes have sufficient gap. The planes should have sufficient separation margin between the two planes. The selected plane shall not be the bearing area or vibration area. This is one criteria. We cannot select the bearing area as a selection plane, balancing plane, or vibration area. The balancing correction is in planes is done either by removing the mass by grinding or by adding the mass like cap screw adding, fitting in a predefined threads in the plane. So either you can remove it depending upon the type of plane, which plane it is selected, or you can add mass by adding cap screw. Balancing plane shall be each end of the shaft. As said, it should be sufficient margin, sufficient gap, so it should be further away each end of the shaft. And rotor drawing shall indicate where is the balancing plane. Now balancing of the shaft. So as we have calculated the allowable tolerances for the shaft, so select the two planes of shaft at each end as per the drawing. do the two plane balancing of shaft, which is like with its accessories like shaft seal, etc., but without impeller and tie bolt nut. Residual unbalance of shaft in each plane shall be within the allowable residual tolerances which we have calculated. So this is for balancing of shaft. Balancing of rotor. Selected two planes of rotor at each end as per drawing. Again, you have to select the which plane for balancing of the rotor. Normally, one plane at the front side of impeller and another is a back side. So first you have to select planes. One is a front side and is a back side for impeller. Then install the impeller on the shaft, tie nut and bolt. Do the two plane balancing for impeller with accessories like shaft shield, etc., and the impeller and tie bolts. Residual unbalance of rotor in each plane shall be within the allowable range. Now once it is done, we have two options. Option 1, balancing of rotor is completed. Some manufacturers say it is over, it is done. They don't want to do any correction on the shaft after this balancing. But option 2, we can further do the balancing considering further plane or considering the other plane farther away from this impeller. So balancing of rotor continues. So once the balancing of two planes, front and back side impeller is completed, balancing of rotor is done in two planes. Select the two planes, one is a back side of impeller like this and another is this, maybe could somewhere here and because this should be indicated in the drawing, so do the two plane balancing of rotor and residual unbalance of rotor. Each plane shall be less than a normal residual limit. So this is how that balancing of single stage rotor is done. So I hope you have enjoyed this. Thank you for watching.